Okay, hello everyone, welcome back. So this is another data analysis video. Again, using Python, working in Jupyter Notebook. And today, or in this particular video, I'm going to demonstrate how to create some simple histograms to visualize the distribution of scores on a variable. And I'm going to do that using both the matplotlib and seaborn software libraries. I'll also kind of demonstrate some of the many parameters that you can adjust to customize your particular histogram plot. Okay, so to start with, as ever, I'm going to import the necessary software packages, libraries that I'm going to need. So I'm going to import pandas as PD, I'm going to import numpy as np, and I'm going to import matplotlib.pyplot as plt. I'm going to import seaborn as sns, which are these are the common kind of nicknames for these software packages that you see people use. Okay, so having done that, let's get some data to work with, and the data I'm going to use is a data set that is available online. I found it online, and it's basically a spreadsheet, and I think it's from like a PlayStation or some sort of games console version of FIFA football game, and it's sort of ratings and information in relation to the different players, the different characters that are available for different teams. So I'm going to import this and save it as a data frame object called FIFA. I've got it saved on my laptop as a CSV file, so I'm going to import that using the pandas pd.read_csv. And if I run this file, I'll just call the first 5 lines using the .head method. So you can see there's 89 variables, 89 columns, a variety of different things available. It's condensed them here, but if we look at these first 5 rows, you can see, so we've got like names of players, so obviously some quite famous names, professional football players, their nationality, the club they play for, things like that. And as I said, I think this is kind of ratings and data used in a video game, football, FIFA video game. So there's a couple of scale variables here, although likely to be saved as integers. Overall, which I think is the overall rating of the player, and potential. So if I think what we'll do is just use this overall rating variable to look at the ratings, the distribution of kind of overall ratings for these professional football players. And to do that, I'm going to use this. First of all, I'm going to use matplotlib. So I'm going to call plt, which is matplotlib, the nickname I gave it, and the method I'm using is this .hist method. And in parentheses, I'm basically specifying the FIFA data frame object and the variable that I'm interested in using this dot notation. So FIFA.overall will give us, if I run this particular cell, will give us a histogram plot, really basic histogram plot, showing the overall rating, skill, ability, I'm not sure what it is, for the FIFA players in this particular data set. And I think there's quite a few. I think there's a lot of maybe like 10,000 entries or something like that. So yeah, if you look, we've got a few thousand so thousands of players rated here, I guess. Interesting way. So an interesting thing to note here is you can see when I've called this object, it's created the plot for us, and it's also put an array of the actual the variable values that are being plotted. Okay, so that in a notebook like this where we're just kind of working with it, that's not too much of an issue. But if you kind of wanted, if you were creating a plot that's look nice and professional for some sort of publication, you probably don't want this kind of array bar contain object of 10 artists, etc. like that. You probably don't want that, and we can actually suppress that output by using this plt.show method. And if I run that again, you'll be able to see that array has disappeared. Okay, so that's kind of worth keeping in mind. That's so when you specify plt.show, that's kind of what it does. It sort of tidies that up, so you're just left with the plot. Okay, so you will notice on this particular plot that the matplotlib has chosen its own default based on what it thinks is the best default to present this data to you. And you can see the scores range from probably like low 40s or about 40 up to about 100 in terms of ratings, just short of 100, the mid sort of 90s, something like that. So this scale is actually rated on a scale from 0 to 100, but we're only getting part of the scale on the x-axis here. So perhaps though we want to change that, and we want to see the whole scale on the x-axis so we can see what the real distribution of data values is. It kind of looks like this is quite nice and neat and normally distributed in that sense, but we may be by allowing the computer sort of to specify the size of the scale that is plotted on, we may be deceiving ourselves a little bit visually. So what we could do is change the bin size here, and then get matplotlib to plot all of the bin size, all of kind of the scale on the x-axis. So to do that here, there are a couple of ways to do this. You've got this keyword argument bins, and you specify either how many bins you want or the size of the bins. And one way I've done it here is I've created this new object called bins, and I've passed it a list of values with a kind of with cut-off points for different bins, essentially. So then what I've done is I've called the histogram again, but I've added, similar to the argument above, but I've added this bins keyword argument. So I've set the bins parameter equal to this object bins that we've created above here. And if I run that, what you can now see is that it's created the scale all the way from 0 to 100, which I think is the true length of that particular scale. Or you can see the frequency counts are quite large. There's sort of around the 60 to 70s, there's close to 10,000 players kind of ranked in that skill range. But by changing this x-axis, you can see the actual distribution of the variable looks considerably different. Okay, and maybe we could tidy that up a little bit more and give ourselves a little bit more information, and we could, having specified the size of the bins, maybe we want x ticks, markers on the x-axis that represent the size of the bins we've specified. And I've done that here by just adding this extra bit of code saying plt.xticks, and I've asked for the xticks to be the same as the bins object. So if you run that, what you should see now is it goes up in tens on the x-axis, essentially the scale. Okay, so we can build on this a little bit more. We've got a histogram that shows us the distribution of this variable, but maybe we want to kind of add some features to that and customize it a bit. So we can add a y label, y-axis label, x-axis label, and a title. So here, to do that, all I've done is plt.ylabel, and I've passed it this string object, this text, number of players. X label is going to be skill level overall, so that's what the overall variable is measuring, skill level. And then for a title, I've basically just passed it this string object, distribution of skill levels. So if we run that, it's just adding a little bit more detail to the same plot. You can see now we've got labels on the x and y axis, and we've got a title of some sort. And there's lots of ways you can change the size of this title and customize these things. And in order to do that, I'm just basically showing a real simple approach here, so of how to get real simple histograms. There are lots of different options, and to find out what they are, I'd recommend going to the matplotlib website and looking at the guidance and on there to see what all the different attributes are and things you can change. So we could also, a couple of things, I'll just demonstrate a couple of other things, and then we'll move on to looking at other seaborn So you can change the color of your bars as well, and you do that by adding this color keyword argument. And I've just passed a string with the letter lowercase letter r in, and if you run that, so let's change the color of our histogram to red, quite bright. Not sure whether you'd actually want to use that. The default is obviously this kind of like this blue color, which is fairly easy on the eye. Another example of that, you can also, when you pass in a color, I passed in R here for red. There are a few others. I think if we pass G, it'd give us green, something like that. But you can pass a hex code as well. So you can use a color picker with a hex code, which are these like 6-digit codes consisting of numbers and letters. So hash FFD54F here. It's just a random one I've decided to put in. And if we run that cell, that obviously comes out as some sort of pineapple yellow colour. A bit gaudy, I'm not sure you'd want that as the colour of histogram, but it just illustrates the different ways you can set parameters and use the different arguments, some of the different arguments that are available. Okay, so let's look at some slightly different data. So that was the FIFA data, just to show some basic histogram plots. I'm going to import a data set and save it as a data frame object called DF. And this is kind of game theory research where participants play like a common pool resource game. So we've got a number of different, if I run the .info, we've got a number of different variables here that measure different things. We recorded different things in this particular research, such as income rank, employment rank, crime rank. This was kind of ratings for the neighborhoods where people lived, and then some of the game, we've got some kind of decimal floating point scale variables like CFC mean and mean consumption down here, which was kind of one of their consumption choices in a common pool resource game, which is one of the dependent variables. So let's just kind of create histograms of a few of these, just to see what they look like. So plt.hist df.crime rank. So if I run that, basically it's just going to create a histogram plot of the crime rank variable, and you can see it's on this quite big scale up to about 30,000, I believe. Higher values represent lower rank in terms of crime, and it gives us these frequency counts for the different neighborhoods that participants lived in. We can plot a similar sort of thing for CFC mean, which was, so this is a kind of questionnaire scale that was used in the research, and it's called the consideration of future consequences. It's a scale that measures the extent to which people discount the future or consider the future consequences of their actions, of things they're doing when in their day-to-day life, and each participant has a mean score on this particular. I believe the CFC, I think it's a questionnaire scale developed in like the 90s, probably 1994 by Strathman and et al. So let's just have a look at that in relation to this data set. So yeah, what we're seeing with both of these variables is they kind of look like they're slightly positively skewed. But one of the reasons I'm sort of bringing this up is we can, as we'll see in a second, we can sort of deceive ourselves as to the shape and distribution of our data with the size of bins we use when we're plotting a histogram. Okay, so I'm going to plot another one. Mean consumption was one of the dependent variables. How much of a resource the participants consumed when playing a common pool resource game. And I'm going to actually specify above, when we did the FIFA stuff, we kind of created this object which showed the cutoff points for our different bins, how many bins we wanted. So altogether, we specified like 10 bins. As an alternative here, you can actually specify just the number of bins, and it will kind of split the data equally. So if I run that, you can see there we've got a very kind of strangely distributed variable I'm going to run this again in seaborn, and you can see like the default that it picks. It can create a quite deceptive impression as to the shape of the data. But one more, we'll go on to seaborn in a second, but one other thing that I will just kind of illustrate. So all these so far have been used, we've plotted these using matplotlib. And one other thing is we can create like small multiples, we might call them. So we can create like grids of histograms next to each other. So all I've done here is I've no particular reason for it, just other than just to demonstrate. I've kind of created two objects, distribution 1 and 2, and I've specified two different variables. So data frame, from the data frame, df object, education skills rank, and then the second one, distribution 2, is the variable income rank for the participant's neighborhood. And I'm using this fig comma, and then I'm setting AXS equals to PLT. So I'm using this dot subplots method, and I'm specifying I want kind of one row but two plots. So 1, 2, Sherry equals true, tight layout equals true. You'll kind of see what that means in a second. And I'm specifying that the first, remember it's zero index. The first plot is going to be distribution 1, this one, and the second one is going to be the first indexed is going to be distribution 2. So if I run that, you can see, notice I didn't use the plt.show kind of method to suppress this array output. But you can see what we've done here is plotted both of these variables next to each other. So it kind of, there might be some reason that you could put, maybe it make more sense to do this type of small multiples if you're comparing different groups, distribution of different groups or something like that. But it's just, I just wanted to illustrate it's something you can do using matplotlib. Okay, so let's look at similar plots. So using seaborn, and remember seaborn is built on the kind of matplotlib base, and all the plots I'm going to create in seaborn are going to be based on this mean consumption variable here. So that kind of distribution of data. So the nice thing about seaborn, as you will know if you've seen any of these other data visualization videos I've created, is the syntax you can use is kind of much you can do a lot of stuff in one line, whereas rather than kind of lots, 4 or 5 lines of code for matplotlib. So to do this, the command's slightly different. I'm using SNS, so I'm calling the seaborn library, and in this case, where we used hist for matplotlib, it's histplot for seaborn, and I'm specifying the data frame data, and the x value to plot is that mean consumption variable. And if I run that, it's kind of picked a default. It creates a very nice looking plot where you can see the different bars essentially for the histogram plot, but you can see there that it looks, distribution of it given that default looks quite different to this. Yeah, so it's kind of just highlights how we can sort of make our data appear a certain way by the defaults that we pick, or the if we're not careful and we don't pay attention to kind of how the plot is being created. So I'm going to call it again, but this time I'm going to specify a bin width of 5. And now we're overriding that kind of default that seaborn's just selected itself. With a bin width of 5, we can actually see a much similar distribution to the one that we got when we asked for kind of 20 bins using matplotlib. Okay, so we could go even further with that and just kind of specify bins equals 40, and that kind of give us a kind of real impression of what kind of this data looks like and where the gaps are. So Obviously, you know, lots of participants sort of made these low to mid-range consumption decisions. Very few made like really high consumption decisions that would destroy the resource in this particular case. So one of the things that is useful when we're plotting, and it's kind of quite a nice option, is to ask for a kernel density estimator to be overlaid on a plot. So if I specify this argument KDE equals true, it will create like a what is effectively a probability density function, probability distribution function maybe, for the variable. And notice I've not specified the bin width, so it's going to create this plot for us. And we don't want to create the illusion that we don't want to fool ourselves into thinking it's normally distributed. So if I run that, you can see there this line here that's being plotted is the kernel density estimate, the KDE line, and it's sort of it's a useful way. It's telling us that the shape, it's telling us something about the shape of our data, what it actually looks like. It's not giving us this impression that it's kind of normally distributed. Okay, so a couple of other options that are available. There are so many, and obviously Seaborn has its own website. The software library has its own website, and you can look at the various arguments you can use. But what I could look at is, in relation to this data, we could look to see if there's a difference in consumption between based on some sort of categorical variable such as sex, which is something that is recorded in this data set. And to do that, I've just set hue equal to sex. Okay, so hue being the different colors. And you can see what it's done is it's plotted males in orange and females in blue. They're kind of overlaid, so it's hiding the orange is looking grey, unfortunately. But it's kind of useful to be able to do this, because it's allowed us to separate the data out based on groups. And you can obviously see that most of the participants here were female and not male in this particular study. We could change this. So condition was another categorical variable for this particular research, and this was kind of how much information participants had about the game, about the available resource. Some had an uncertain amount of information, some had a certain amount of information about how much resource there was, and for some it was ambiguous. They kind of had some information, and as the game went on they gained a bit more. But we can use this. We could if we specify, you know, a category with categorical variable with more than 2 values, it'll create a similar sort of thing. If we pass that using this hue keyword, because where these are overlaid and it's kind of hiding, it's a bit hard to interpret here, because you know these are just looking great because there's multiple colors stacked on top of each other. And we could sort of get around that a bit by using this multiple equals stack argument. And if I run that, what you can see now is that it's kind of stacked the different colors on top of each other. So you can see what proportion of, rather than, you know, here we've got 6 counts in the uncertain condition. Those we've got for, you know, for between say 10 and 20. We've got a total of 10, and you know this blue bar here now will represent 6 of those, and this would be the other 3, and this probably 1, the ambiguous condition. So it's kind of useful to stack them up like that. Makes it easier to interpret what proportion of each kind of value in the data set, which is made up by which group essentially. Yeah, so another kind of I kind of was just playing around with these. Another quite interesting argument you can pass there is this element equals step, and what it will do is it will kind of like create each of the groups like it's like the outline is step. So orange would go here like it's a step, and then there's a gap and it goes up here. and then along there and down there. But similar, we've got similar issues with that. I think that could, if you didn't have many variables plotted, that could be a good way to look at it. And if they weren't overlapping considerably, but we have a similar issue to this one here, where it's hard to tell which colour's which because they're overlaid on top of each other. Just a couple more arguments here. If we press, if we add this fill equals false argument, it'll plot the data for us with this kind of default plot, but you will just get the bar lines essentially. But my personal preference is, so what I'm going to do here is plot this mean consumption again, but I'm going to specify quite a narrow bin width and add the KDE, the kernel density estimator. So that sort of gives us a much better impression about how this variable is distributed. So sometimes I think it can be a case of you can deceive yourself as to the distribution of the data. This one wasn't too bad, but the actual trend is much more pronounced when you specify a much narrower bin width, such as that. You can still see the KDE, the kernel density estimate is quite similar, but yeah. So this kind of my preference is for this particular plot. We're not hiding anything. We're not making the distribution of this variable look better than it actually is. Okay, so hopefully that was useful. Just a quick intro to the various things you can do in matplotlib and in seaborn when plotting histograms. So where you're plotting the distribution of a variable. I'll create a separate video about kernel density estimators because I think they're quite a useful thing.